In this video lesson, we'll be comparing two linear functions. One of them is given as a table with the title Jean's descent. The other one is an equation called Fred's descent. And the context to the problem says Fred and Jean are hang gliding. Fred is 600 feet above the ground, and he's descending at 20 feet per second. Jean is descending as shown in the table. Question asks, what is the rate of change for each hang glider? Well, Fred's rate of change is more obvious than Jean's because this is written in slope-intercept form where m is my slope. So Fred's rate of change is -20. Jean's rate of change, I need to figure out the change in y and then the change in x. To go from 480 to 465, it's -15. To go from 0 to 1, it's +1. Change in y over change in x is going to be -15 for Jean. And then we have to interpret this in the context of the problem. So that would tell me that Fred is descending. Fred's rate of descent is faster than Jean. Now that's kind of an odd thing because the number -20 is actually less than -15, but in the context of the problem, he's coming down to the ground level faster. Question says, what's the y-intercept of each hang glider? I need to go back to my table and go back to my equation. The y-intercept for Fred, it already told us he started 600 feet above the ground, so that's his y-intercept. And Jean's y-intercept is right here. 0 seconds into the hang gliding descent, he was at 480. So again, Jean was 480, Fred was 600. And what does that tell you? What does that mean in the context of the problem? It says Fred started higher in the air than Jean did. How many feet above the ground are Jean and Fred at 5 seconds? So 5 seconds, we can find that on the table. We can also find that in our equation. So let's check that out. 5 seconds. Remember, this is decreasing by 15. So 5 seconds in, Jean is at 405 feet. 5 seconds in, I'm going to put 5 in place of x here. It's -100 plus 600. 5 seconds in, Fred is at 500 feet. So we have 450 for Jean and we have 500 for Fred. And what about the x-intercept? The x-intercept, what that represents, think about this now. When a graph goes through the x-intercept, the y is 0. And what were we measuring? We were measuring the height. So the x-intercept is the time it takes for the hang gliders to what? To reach the ground. And so basically we look for the y value of 0. And this one here is going to be harder to determine, but right here I can just set y equal to 0 and solve for x. So I'm going to subtract 600 from both sides. I'm going to divide both sides by -20. And I get 30. So I know for Fred, he hit the ground 30 seconds in. And how would you go about figuring out for Jean when Jean would hit the ground? What do you think you could do to figure that out? That's a little bit harder.